In this experiment, we are going to see how to transmit sensor data from NodeMCU to an IoT cloud platform known as Thingspeak. So you can type Thingspeak, then you'll be getting thingspeak.com. You can log into that platform. So the Thingspeak IoT platform will be looking something like this. First of all, we need to log into that. So you can click on sign in. We need to give the official email address here. So you can create one new channel here by clicking on this new channel button. So if this channel window is not visible for you, you can click on channels, then select my channels. Click on channels, select my channels. So then you will be able to see this channels window. Then click on new channel. So since it is a free platform, you will be able to create a maximum of 4 channels only. So I am planning to delete one channel. So for time being I am deleting this channel. For that you can click on that channel whichever you need to delete. Then click on channel settings. Then you can scroll down. When you are scrolling down, you can see delete channel. So the channel has been deleted. Now I can create a new channel. So click on new channel. Can give the channel name as a temperature, and for each channel at least one field should be there. One field means field is a something like a variable which holds the data, or field is used for pointing to a data in Thingspeak. So for time being I am going to send only one sensor data to this channel. So I am going to use only field 1. If I want to send multiple sensor data, say if you want to send 2 sensor data, then I can configure field 1 and field 2. For time being I am sending only one sensor data, so I am selecting only field 1, and instead of this label I am giving the label as temp, T-E-M-P. This is my field 1 name. So the channel creation is over. Then you can scroll down and click on save channel. So now you can see that a channel has been created with the name temperature, and it is having one field of name TEMP. So whatever sensor data you are transmitting from NodeMCU, that sensor data will be plotted here as a chart by default. So that is what you are going to see. So this is how we need to set up a channel in Thingspeak. Now we will move on to the NodeMCU code for transmission of the sensor data from NodeMCU to Thingspeak channel temperature with the field TEMP. So this is a code for transmission of a sensor data from NodeMCU to Thingspeak. So here we need to enter the SSID, password, host and write API key. SSID is the SSID of the hotspot. Password is the password of your hotspot. Host is nothing but the server address to which you are going to write from the NodeMCU. In my case, I am going to write into Thingspeak server. So the host address is api.thingspeak.com. Then the last one is a write API key. It is same as or almost same as the API key which is used for writing in Adafruit. So similar to Adafruit, in Thingspeak also API key is used for identifying the user. So how will I get access to this API key? For that you can go to Thingspeak and you can go to the channel. This is a channel what I have created just now. In this channel you can see a tab known as API key. You can click on that. When you are clicking on API key, you will be getting the API write key as well as API read key. For time being we are going to send the data from the NodeMCU to the Thingspeak. So we need to have only write API key. So this is a write API key. You can copy this and you can come to the Arduino, can paste it here, right? So before uploading the program, you need to enter the SSID, password, host, and the API write key, which is what you are getting from the Thingspeak. Then inside the setup function, you are configuring pin number 2 as output. Then you are configuring the serial port with 115200 baud rate. Then Wi-Fi has been initialized using SSID and password. Then the status of the Wi-Fi is checked by using a function known as Wi-Fi.status. Right? So Wi-Fi.status will return the value WL_connected if the Wi-Fi connection has been established properly between the NodeMCU and the Wi-Fi gateway or whatever access point you are having. So if the Wi-Fi connectivity is successful, this function will return the value WL_connected. Otherwise, it will be sending something else. So at that time, Wi-Fi access and this parameter will not be equal. So we will be keep on executing in this while loop until the Wi-Fi connection is established. So once the Wi-Fi connection is established, it will come out of this while loop followed by the setup function. Then inside the loop function, first of all, we are going to read the analog data from channel 0, A0. So in my case, I am connecting a very basic sensor, maybe a potentiometer or any other sensor to analog channel A0 of NodeMCU. And I am going to read the sensor data from A0. So for that I am using a function known as analog read bracket A0. So you are reading the ADC value from channel 0, that is A0, and you are storing into a temperature variable. So that temperature variable I have initialized in the top as int temperature. So to that temperature value, you are going to store the analog value. Then you are creating an instance of Wi-Fi client by using Wi-Fi client space client. Then you are defining the port as 80. This is a normal web server port. Then you are checking whether the client is connected to the server. For checking that, client.connect function is used, and in bracket you are giving the host address, that is the server address which we have given in the top, followed by the port address, that is 80. So client.connect is used for establishing a connection between the client and server. Here my client is your say desktop or laptop or whatever it is, or your NodeMCU basically. NodeMCU is a client and your server is the Thingspeak. So this function will return a value 1 if the connection is successful. If the connection is not successful, it will return a value 0 and will be coming out of this function. Then the sensor data is sent to the Thingspeak using a function known as send Thingspeak. So the send Thingspeak function is defined here. So send Thingspeak consists of nothing but a string consisting of a particular group of strings, that is starting with the get method. Get method is used for getting a data from the server. That is done by using the get method. Then followed by update question mark key equal to the API write key. Then and field 1 equal to the temperature data what we are reading. Then followed by HTTP 200 OK. Then followed by the host and the connection. So this format from where will you get? This is already available in the Thingspeak. In this format only you are able to write a particular data which is provided in field 1 to the Thingspeak. So for that you can go to Thingspeak. In the same API keys of that particular channel, you can see that write a channel field. This is how you are going to write to a particular channel in Thingspeak. Get method followed by the host address / update question mark API key and this is your API key, and field 1 equal to whatever value you need to send. So if you want to send a particular value to my ID in Thingspeak, you need to send the value here. So if I am sending a value 10 here, that 10 will be written on to my channel under my user account. So this is how you are going to send the data. That same thing is written here in the form of a string. So string command equal to string of gets. With that get command, you are concatenating all these values. Plus update key means you are concatenating this with the get. Then write key you are concatenating field 1 followed by the temperature. Once all these things are done, we need to send the HTTP host and the connection. Connection you should close it. So HTTP you are sending in this format. Host will be sending in host colon host, then the connection. This complete string you are returning from this function. So you are returning this whole string as a command. So that will be sent to client.println function. Client.println is used to write this particular command from the client to a server, right? Client.println, serial.println means you are printing the particular message through the serial port, or you are printing it through the serial port. Similarly, client.println, here client means it is a Wi-Fi client. We have already defined here Wi-Fi client. So you are printing or you are sending this command from the Wi-Fi client to the server. What command? This is a command. So when you are sending this command in the form of a string, whatever value is present in this temperature variable, that will be written on to my channel in Thingspeak. That is done by client.println. You are writing command from the client to the server. Then for identifying whether the value has been generated properly, you are checking whether the temperature value is greater than 700. If it is greater than 700, you are making pin number 2 as high. Else you are making pin number 2 as low. Then the same temperature value is also printed through the serial port so that we can debug what is happening there. So this is how you are writing a program for sending a sensor data from NodeMCU to Thingspeak. So now you can upload this program. So before uploading, you need to verify that you have entered the SSID and password properly. So I have entered the SSID, password, API write key and the host address. Now I can upload the code. So now the program has been uploaded successfully. Now you can click on serial monitor. Then you can reset the NodeMCU. Once the NodeMCU is resetted, you can see the command that is being transmitted here, because as the last line of the send Thingspeak function, I have given serial.print command. So whatever command is transmitted, that will be printed in the serial port also. So you can see the command here, get /update ? Key equal to the key and field 1 equal to whatever value it is read from the NodeMCU channel 0. Then followed by the HTTP request 200 OK, host address, connection close. So using this you are sending the data to the Thingspeak. And when the potentiometer connected to A0, if I am rotating it, you can see that the value will be getting changed. You can see now the value of field 1 was previously 109. So based on whatever potentiometer value you are setting, the value will be changing here. You can see now it is 33, 58, etc. So by changing the ADC value, the value which is sent to the Thingspeak also will change. Now we will go to the Thingspeak and we will click on the private view. This is the temperature channel what you have created. You can click on private view. When you are clicking on private view, you can see the chart here, right? Now the time is 8:30. You can see at 8:30 30 seconds we are having some value, and this value will keep on changing. When the potentiometer connected to A0 is changed, can see the value also will change. So now you can see that the value which is sent from the NodeMCU to the Thingspeak is getting changed because I am changing the potentiometer connected to A0. Whenever I am turning the potentiometer connected to A0, the ADC value read from A0 channel will change, and that read value is sent from NodeMCU to the Thingspeak IoT Cloud Platform. So this is how you are sending a sensor value read by NodeMCU ADC to the Thingspeak Cloud in real time. So this is a demo of the experiment what you have done. You are sending the ADC value from the NodeMCU to the Thingspeak, and that is getting plotted there. So here in NodeMCU we can see the channel A0. Now I am touching the A0 channel with my hand. So the static electricity present in my hand will be sent to A0, and the ADC of the NodeMCU will read that, and that is being sent to the Thingspeak Cloud, so that you are getting a spike here. Then after some time, when I am removing my finger, the data will be settled down to 0. So you can see that in just a few seconds, because it is a free platform, it will take few seconds to update the value. So you can see that the data has been updated, and when I am removing the finger, the data has been come down to 0. So instead of touching it and checking the output, you can connect a potentiometer to A0, and when I am turning the potentiometer, the ADC value will be changing, and that value will be sent in real time to the Thingspeak Cloud.